Good evening, everyone. This is the Catch Me app that we created. Our team name is also Catch Me. This is the app that keeps you running. It's an app where you race against your friends. Our team consists of Mace, Kirill, Gonzalo, and myself. The outline of the app is that players across the world can compete against each other in races of various distances, and location tracking calculates each user's distance covered during a race and determines a winner. So I'm now going to move to a YouTube demonstration of the app.
Yeah, let's have a look at how our app looks in action. So yesterday, me and Gonzalo actually went to a park and recorded the video. We're surprised to find out how well it actually worked, because it only took us 3 takes, three 500-meter races. So on our homepage, yeah, you can see 4 options here, how to play with instructions. Then we can create, find a race, and the leaderboard. So let's go and try create race. So in this page, you can select your desired distance as well as enter your name. So yeah, we choose 500 meters and name ourselves as Luigi. And here in the lobby, I can press that I'm ready. And because I'm a host, I will be able to see the press start button, which unfortunately looks a little bit cropped. We can go ahead and start solo, but the whole point of Catch Me is that you can actually race it with your friends. So let's wait for Mario to join. Mario can use the unique lobby code that you can see on the top. Yeah, he's found it. You press ready, and now the button reappears because everybody is ready. And now we can go to the actual race. So Luigi and Mario are racing, and on the bottom of the screen, you can see the timer that helps you track your pace and let you know what score you're going to expect at the end of the race. So this app is not limited by users. We can have 1 person, you can have 10. It doesn't matter. So as long as the 2 keep running, our advanced algorithms calculate their distances, their geographical coordinates change, update and get requests are sent back to the database and fetched back so that everybody can see everybody's live distance. So David, if you can skip over to the end of the race. So this is quite a tight one, but Luigi ends up taking it all. And as soon as he does, the app will notify him that you have finished the race. And now we just need to wait for Mario to finish. Yeah, so now it's taken to the end of the race screen. And here we can see everybody's scores, as well as some general information about the race, such as the distance, time, and the score. So we also have a leaderboard. So if you're lucky enough and fast enough to be in the global top 10, you will appear in the leaderboard, which we'll show you right now. I think it's just in a second. Yeah, so if you pause here, yeah, so these are actually from the 10-meter race. So if you really want to get into a leaderboard, we recommend you pick that option because it's not split by distance just yet. Yeah, that's the demo over. So back to David, who's going to talk about our languages and frameworks. Thank you.
So that was the video, and I'll just go over the languages quickly. So for the back end, we used Node, we used GraphQL with the Apollo server to create an API. We used Jest to test our resolvers, SQL ISO with the Postgres SQL for managing objects in the database. For the front end, we used React.js. We thought about React Native, but with a time constraint, we felt that that would be a step too far. We used the Apollo client for connecting React to the GraphQL API, and we used Cypress for testing page interaction on the front end. We also used Travis and Heroku.
Okay, I'm going to talk about our planning and workflow processes. Well, we came up with the idea, actually Kirill came up with the idea, and we agree regarding about the technologies that we wanted to use. So we were all aligned to that idea. Then we went through the user stories to get a better idea how the user is going to interact with the client. And then we decided to build an MVP. Then we diagram our classes and the tables, relational databases, how they're going to interact between each other. And then at the end, we design how the backend is going to interact with the front end and vice versa. And then regarding the research and the self-learning, we were doing both as a team and individually. And individually, when we came up with an idea, then we jump on a call and share our knowledge. And then if it was a good idea, we implemented it. And then, yeah, basically that's it regarding research. Then the meetings were structured basically at the beginning, 3 to 4 meetings a day, the very first week. And then the second week, as we already had like the baseline for the app and all the backend running, we started working more into pairs, actually, more individually as well. And then regarding the tasks, we use Leaderboard to split very clear the tasks that each of us needed to do. And then regarding the GitHub, we split the project into the backend into basically 2 repos, and then we were working on branches. And then once our tasks were done, we shared that, and then we reviewed them, and then we merged to the main one. So was everything accorded. And then I'm going to talk about the goals of the team. Well, we wanted to build something that we can use and we want to use, actually, something funny at the same time. And also something important we want to use in this project was the fact that we wanted to consolidate the previous skills with JavaScript and React. And also we wanted to combine them with a new technology, such Apollo client, Apollo server, and also GraphQL. So yeah, and then finally, it was a challenge to get familiar with the geolocator tools that is provided by JavaScript, which was really good. Yeah, so for my part, that's it. Yeah.
So that's on to Mace with the difficulties.
Travis didn't pass often due to the clashes with other texts that we used. In the front end, we couldn't figure out how to use it with Cypress, as it needed to start a new server. With Zoom, the fact that we had to keep on in and out of different rooms, it caused issues and having to wait for the other person. Due to the time constraints, we split our teams, so we had a front end and a back end team. It gave us a lot of efficiency, and it enabled us to work much better with knowledge sharing. For the databases, we initially wanted SQLite, but it wasn't the best production choice for us. MongoDB wasn't available on Heroku, so we ended up sticking with Postgres. To the tracking location, we wanted to use the Google Maps API, but it actually costs money, and the amount of requests made, it would cost too much for an app like this. We ended up choosing a native JavaScript geo functionality. For testing, we started off with Jest and React testing library, but it just got a bit messy, so I ended up moving on to Cypress, which was more user-friendly. ESLint, it caused us numerous issues when pushing to our Git repos, which caused us problems with coordination in the front end with merge conflicts. For our achievements, I would say the thorough planning allowed us to jump straight into it, working on the back end and the front end simultaneously by referring to our diagrams. We built a solid back end that deployed very quickly to Heroku and didn't need any changing. We had 97.5% coverage. David and I worked on the front end without any barriers, as everyone was on the same page. And as for time constraints, it enabled us to we kept a nice stable flow. We didn't have to worry about it. I think that was good. The inspiration with this app was the easeability was Among Us. So it's easy to navigate, an arcade style, and no authentication, so anyone can join. And because we were making too many requests to our backend, that caused us issues. But in the end, we optimized our request cycle really well, which made the app more snappy. And David?
Yeah, we just wanted to thank our cohort because it's been great. So thank you all.